about this one on the board. The way we're trying to do it is, well, I haven't made this very clear in the video last time. So if you want to use add a sine rule, okay, just go back a little bit. If you want to use add a sine rule or cosine rule or the area of the angles, I need 3 pieces of information. Okay, what's the 3 pieces of information mean? Angle, length, okay? 2 angles or one side, or one side, or 2 side, 1 angles, or like 3 lines. Okay, 3 angles won't work. Okay, 3 angles won't work. Okay, 3 angles not working. So the 3 pieces of information will be at the 2 side, 1 angle, or 2 angle, 1 side, or 3 sides. You need 3 pieces of information at least to use cosine rule or sine rule. So for sine rule, you definitely need angles and the opposite length. Okay, so like you always confused about like when I should use cosine rule, when I use sine rule. Well, sometimes you can use both sine rule and cosine rule, and you need to pick the one like you think which is appropriate. But the very obvious thing is, if there's no angle and no length opposite to the angle, you can't use sine rule at all. Okay, you can't use sine rule at all because you need to at least know the ratio. Okay, at least know a ratio. If you don't know any ratio, what's the point of talk about sine rule here? So it's all the ratios are the same. So you must know angle and the opposite length in order to use the sine rule. And then you can have any other piece of information, for example, a side or an angle, doesn't matter which one you have. So you can work on that later. But like angle and opposite length is very essential for the sine rule. And for the cosine rule. For the cosine rule, you can have 3 sides. Okay, you can have 3 sides. I can use the 3 sides to work on angles. Or you can know any 2 lengths and the included angle. Okay, any 2 lengths and the included angle to work out the opposite side. Okay, the opposite side. So that's when you can use sine rule and cosine rule. So just make it a little bit clear. And also for the area of triangles, you need 2 lengths and the included angle. Okay, you need 2 lengths and the included angle. So I need to know this and the angle here. I need to know A, B, and the angle inside. Okay, not any other angles. Okay, not any other angles in order to use the area formula. In order to use the area formula. So for cosine rule, 3 sides or same as that shape will work. Okay, will work. That's how you decide when I can use which one. Sometimes you don't need to really consider sine rule or cosine rule. It depends on what piece of information you have and what you're trying to work out. So that's just a general idea. Okay, this is just a general idea when you can use them. So let's come to this question here. Okay, I think everyone already did this question on your paper. Like, I'm not going to write the full solution here, but talk about what's the idea behind it. Okay, so what we need to think about. So, well, I have the angle already. I don't want to draw a line to split the angle. Okay, I don't want to make the angle disappear because I don't know what the left hand side will give me, what the right hand side will give me. So I will just add a line here. Okay, I will just add a line here. So I have created 2 triangles. Because we talk about sine rule, cosine rule, and the area of triangles, we need triangles. So I have created this triangle here. And look at those 2 triangles. What do we have? If you look at, well, I will label that as A, B, C, D. If we look at it, and if we see the top triangle, how many pieces of information do you know here? 2. Okay, only 2. 2 pieces of information is not enough, okay, for use any rule, okay, to use any of those 3 rules. So it's not enough. So if it's not enough, we look at the bottom one first, to use the bottom one to help us, because they share the same length. Let's see if I can use the bottom one to find the length, like to have a 3rd piece of information. That's what I'm thinking when I do this question. So I look at the BCD triangle, okay, BCD triangle. I can see, yeah, I have 3 pieces of information, 5, 6, and 65 in between that. So I can use area of triangle, and I can also use the cosine rule. What's the reason I can't use the sine rule? What's the reason I can't use sine rule? Yeah, there's no opposite lines. Good. So there's no opposite lengths. So I know the only angle I know is 65 degrees, but I don't know opposite. Okay, I don't know the opposite, so I can't use sine rule here. So I can use area of triangle. So I have the area of triangle BCD that equals to a half times 5 times 6 times sine 65 degrees. Well, I'm not going to evaluate it now. So I have worked out the triangle's area at the bottom, so all good for the bottom one. But I can't work out the top one, so I need a third piece of information. Again, I can use cosine rule here because I know the BD squared will equals to 5 squared plus 6 squared minus 2 times 5 times 6 times the cosine 65. And I can square root both sides to find the length of BD. Okay, to find the length of BD. I can find the value of BD now. So I find the third piece of information in the triangle ABD. Okay, in the triangle ABD. So third piece of information, the information I know is the length of three sides. Okay, the length of 3 sides. Is that possible to use sine rule? What I'm missing? Angles. Can I use the area of triangle yet? No, what I'm missing? Okay, I'm still missing angles. So because I'm missing angles to find the area and I can't use sine rule, the only thing left is the cosine rule. That's what we can use. Okay, that's the only thing we can use. So I can work out any angle. Okay, I can work out any angle. But because if you try to find the angle of A, I need to use the length AB and AD. That's given. If I'm trying to work out the angle ABD, like this angle here, what length I need to use? I need to use the length AD and BD to work out it, right? But like AD and BD is something we don't want to keep using BD in the equation. We want to make it like on the left hand side because that's something we already work out. Like I want to not accumulate errors if you have errors already. And also BD is a quite long expression. That's why I might find A is easy to find. Okay, the angle A is easy to find. Well, they're all the same. They basically all the same, but BD is too complex. That's why I want to make it on the left hand side to be the opposite. So what I will have is BD squared equals to AB squared, which is 4 squared plus 2.5 squared minus 2 times 4 times 2.5 and times the cosine theta here. Okay, BD is what? BD is given above. I can change the whole left hand side to this expression here. Okay, BD squared is just that. So I can put this here and then put that into the calculator to find what is cosine theta and then evaluate theta after that. After that, I can find the area of triangle ABD. That equals to a half times 4 times 2.5 times cosine theta. So what's cosine theta? Cosine theta is BD minus this and divide by this. Okay? BD minus that and divide by that. That's the cosine theta. I can just sine theta. I can work out the theta from that and can sub the theta in to find the area. So that's the thinking why I'm doing this. Okay, that's why I'm doing this. Why we can't use this rule, why we need to choose that rule. That's what I'm thinking about. Yes? BD? Oh, okay. I'm not, BD is even above there. Well, because I can work out this angle as well. Say that's alpha. I can work out that angle as well. So if I want to set up an equation like say what's alpha? Like alpha will be 2.5 squared equals to 4 squared plus BD squared minus 2 times 4 times BD and then cosine alpha, right? That's the equation we have. But because BD is a really long expression, can you see that? You don't want to use it twice in the equation. That's why I want to find that angle on top. To only have BD on the left, not involve that messy expression again and again in the calculation. But it's nothing wrong to use this. Yeah, this one? Yeah, BD squared minus and divide that. Yeah. Any more questions for that? Okay, that's this question here. And this one, well, most of us spend a really long time on work out this one because most of you draw a line here. Well, it's a good thinking because you're trying to see two triangles. There's nothing wrong start with this. But what you realize is the 58 disappeared. It's not 29 and 29 on each side because it's not 22 and 18 is not even the isosceles triangle here. So it's not isosceles. I can't cut the angle in that way. I don't know what proportion to give to the left, what proportion to give to the right. So that's why I can't cut there. Because the only piece of information I know for the angle is the 58. And I make the 58 disappear. I can't use it anymore. That's why I can't keep moving. Okay, I can't move it forward. Like that's why this line shouldn't be at here. Okay, shouldn't be at here. So if I can't add the length here, well, the other way we can do is just add the length here. Okay, so if I can say the big triangle ABC to minus this triangle BCD here, okay, ABC minus BCD, that will give me the area of the given shape, okay, the area of the given shape. So let's think about this question again. If I want to work out the area of ABC, that's very straightforward. Okay, the area of triangle ABC, because I know the length, so it's a half times 22 times 18 and times sine 58 degrees. I can work out the area of the big triangle. Okay, I can work out the area of the big triangle. Okay, now let's look at the small triangle BCD here. Okay, the small triangle BCD here. The small triangle BCD, I only have two pieces of information, which is 12 and 8. I need a third piece of information. Okay, I need a third piece of information. So therefore, I need either a length or angle. Okay, it's hard to find the angle. There's no information for angle at all. How I can find the other angle is hard to do. So what I will do is, again, same as the previous question, I use the big triangle ABC to help me find the length of BC first in order to have the third piece of information. So BC squared equals to 12 squared plus 8 squared minus 2 times 12 times 8 times cosine the angle alpha. Let's say that. Say the angle alpha here. After I work out the angle alpha, so what's BD? BD is, no, that's cosine 58. Okay, that's cosine 58 degrees. That's BC. So I can work out BC here. Now in the triangle BCD, I can also write BC squared also equals to, that's 22 and 18. And that's 22 and 18. And in the small triangle, I have 12 squared plus 8 squared minus 2 times 12 times 8 and times the cosine alpha. Because I work out BD already, I can sub BC in and to find the angle alpha. And then I can say the triangle BCD equals to a half times 12 times 8 times cosine alpha. That's how I can work out the area. Okay, that's how I can work out the area. So in this one, I can work out the length of BC. In the second one, I can work out, I always write sign here, that's a sign. Always did that. I can work out alpha in the second one, and in the third one, I can work out the area. You just keep putting things in the calculator and work that out. Any questions for these two? You know, that's just a little bit of revision for what we have learned last lesson. Yeah? That's enough, and you can give me the answer after that line. Yeah, put in the cast and then find the answer for BC, find the answer for alpha, and give me an answer here. So you can directly give me answers, but this is important, like this much is important, and you can directly give answers after that. Any other questions? Alright, hopefully I go through this again to give you a clear idea on when we should use different rules, and that's for like using formulas. Okay, those two questions is using formulas. If we can go up to the example 1, please. Yes. You can install that in your CAS. I think application question, you can open the document and then save a document there. Okay, everyone. Let's have a look at this question here. A ship has due north from point A for 40 kilometers to point B, and then has on a true bearing of 100 degrees. Can you label on the diagram where is 100 degrees? Or if you think this diagram is too small to work on, you can make it larger as well. So label for me where is 100 degrees. Okay, on a true bearing of 100 degrees to point C. And the bearing from C to A is 240. Can you show the 240 or equivalent information on the diagram for me, please? Okay, you do that by yourself, and I will label it here, and you can check it. Okay, I said this angle. Okay, this angle is B. This point is A. This point is C. I add another letter here. Like I say, this point is D. Okay, so any letter along the line above it, and this is F. Because it's easy for me to talk about the angles. Okay, just add the D and F on top of it. Just on top of the north to B and to C. Okay. Even you did 100 degrees, what you can tell me, which angle you can also tell me? ABC, what's that? ABC, what's that? 80, yeah. Okay, after you know this 80, what's another angle you can give me? BCD, okay, what's that? Okay, Y is 80. Yeah, parallel lines, alternate angles. Okay, good. If you can see that, that's 80 degrees. So after you know that, what's another angle you can give me? BCA, so what's that? How do you work out that? Yep, 360 minus 240 and minus 80. So 240 plus 80, that gives you 320, and you have 40 left for a full revolution. So that's a 40 degrees. Okay, after you know that 40, what's that? What else you can know? BAC, yeah, what's that? Okay, 60. So in the angles 180 degrees, we have 60 there. Great. Okay, we can see a triangle. What's the triangle here? What's the only triangle here? ABC. Okay, so how many pieces of information do we know for the triangle ABC? 4. Okay, what are they? 3 angles and 1 side. So which rule we can use? Yeah? Sine rule? Because we have the angle and opposite lengths, we can definitely use sine rule. Well, I can't use the area rule yet, because I don't have a piece of information for 1 length. Okay, and I can't use cosine rule yet because I'm missing the information for another side. So I need 3 sides or 2 sides for the cosine rule. So I don't have one more side. So sine rule will be the proper one to use in this triangle without reading the question at all. Okay, without reading the question at all. So we have find the angle ABC. Okay, ABC, we did find it. That's 80 degrees. I don't think we have problem with that. So that's 80 degrees. Find the distance from A to C and find the distance from B to C. Okay, find the distance from A to C. So I say the length AC and find the length of BC. What kind of equation you can set up for me to talk about involve AC and BC in? Sine 40 over 40, okay, over the opposite equals sine 60 over BC, yep, also equals to sine 80 over AC. Correct. Okay, that's sine rule. That's how we set up the sine rule. Correct. So we know we use sine rule. If you figure out you should use sine rule, that's very easy to apply it. So we use sine rule. We have the same ratios for all of this. Okay, for all of this. If I want to solve BC, let's have a look. If I use those two, well, that's 2 equations. If I want to solve BC by using this, okay, by using this, I can do cross multiplication. So BC times sine 40 equals to 40 times sine 60. So BC equals to 40 sine 60 over sine 40 degrees. Okay, that's the length of BC. 40 sine 60 over sine 40, that gives you BC. So if we can do this, that 40 times sine 60 over sine 40. That equals to, well, 1 decimal places, that's 53.9. Okay, if you use your calculator, we should have the same value, 53.9. Can you use a similar way to find AC out for me, please? Use a similar way to find AC out. degrees. I should write degree. It's the kilometers. The unit is kilometers. Let's talk about the length. If you finish it, you can have a look whether we have the same answer here. Bearing questions is always combined with sine rule, cosine rule, and the area of triangle. Well, area of triangles maybe not that much to cover, but like sine rule and cosine rule is used a lot in the bearing questions. Okay, so this is a bearing question, bearing 100 to there, another bearing 240 to there, a triangle here, work out the length for me. So that's how to put cosine rule and sine rule into bearing questions. Do we have any questions for this? Anyone got a different answer? Wants to check whether I'm right or wrong? No? Oh, good. Okay, that's this question. Okay, that's example 1. So bearing questions combined with the sine rule and this is combined with the sine rule, not the cosine rule yet. Okay. If you can have a look at example 2 and sketch the diagram by yourself, I give you 10 minutes to try that. Okay, 10 minutes to try that, and we compare the answer together. Okay, I just checked. Everyone said got this answer. Like we draw this diagram here. I have 1 length, 2 lengths, and I know the included angle. So that's the time when we should use cosine rule. Okay, clarify again, to use cosine rule, we need 3 lengths. Okay, that's the first situation to find any angle. Or we have 2 lengths and the included angle given. That's the time to use cosine rule as well. Because we can't use sine rule, there's no opposite length and angle both given, so I can't use sine rule here. So we use cosine rule. I set up the equation over there. I work out the length of AC, and I add all of them up. That will give me the answer for the total journey. It's not a very hard question here, so that may be the level of difficulty you might have in the test, right? So not that hard. Okay. Any other questions for these 3 exercises? Okay, if you don't have questions, that's the rest of time you do the homework.